Assalamualaikum, my name is Arif. I would like to present to you my final year project 1 proposal with title Heavy Lifting Drone Towards Full-Scale Autonomous Flying Taxi Grab Car, a feasibility study. Okay, my SV supervisor is Dr. Muhammad Hanif Muhammad Ramli. Okay, for the content of this project presentation, it includes introduction, problem statement, objective, the teacher review, methodology, expected result, and lastly, conclusion. Okay, for the first part, introduction. Okay, drone is a flying object or machine that is remotely controlled by humans. In other words, it is called UAV, Unmanned Aerial Vehicle. It could be equipped with many types and many kinds of technologies, depends on the user preference. Based on aerial type platform base, there are 4 types of drone. The 4 types of drone are multi-rotor, fixed wing, single rotor, and hybrid VTOL, vertical takeoff landing. For problem statement of this project, is to prepare a conceptual 3D design model of a passenger drone. The design of the passenger drone must be large enough to fit one person at a time with fully autonomous. Next is to identify a suitable material for the drone frame. The selected material must be adequate with the safety aspect of the user in the future. Okay, last is to make test analysis using FEA of the drone design frame, finite element analysis, such as using CAD software, for example, SolidWorks or CATIA V5. For the objective of this project is to prepare a conceptual design of the drone, to identify a suitable material for the frame, to make test analysis using finite element analysis FEA, to reduce human distance travel between location. Lastly, to compete with other drone projects that are already out in the market, especially in Malaysia. As you can see in figure 4.1, these are the possible drone frame construction. For this project, after making some research, I decided to choose Quad X. Drone can be categorized into 3 different classes, 0 to 150 kg, 150 to 600 kg, and lastly above 600 kg. For this project, we'll be focused on class 2, 150 to 600 kg. Okay, this is the latest update for the top 3 heavy lifting drone in 2020. Okay, for the first one, Firefly System Alta UAV. The payload is up to 6.8 kg. Okay, for the second one, X4 Dragon, payload is up to 136 kg. The last one is DJI Spreading Wing S900. The payload is up to 8.2 kg. Based on the top 3 heavy lifting drone in 2020, it is good, equipped with high technology, but however, it is not good enough for this project, because of this project will be focused on lifting a human from one location to another. So other example of passenger drone that are already out in the market is Volocopter. As you can see, Volocopter is the first commercialized passenger drone in Dubai. The payload is can up to 160 kg. It is fully powered by electric, and it is the first possible drone taxi in Dubai. From the literature review study that I have been made, you can conclude that multi-propeller drone configuration offer the best performance, optimal stability, and trust. So this project will focus on designing drone with multi-propeller base. The frame design of the drone plays a major role in this project. Frame design of the passenger drone plays a major role in completing this project. It must be light enough to allow the drone to fly smoothly. The design must be highly flexible and suitable for wide range applications. Multi-role through-frame design is chosen because it is much easier and can withstand heavy load, strong and uneven in loading conditions. Next is methodology. For this part, I've prepared a flowchart of the initial design process of the passenger drone flying taxi. Okay, based on the flowchart, firstly, I have to identify the passenger drone design requirements. Next, I will proceed to the initial concept and design, probably through sketching. Then using CAD software, I should develop a conceptual 3D model. After that, I should discuss with my SV to confirm the body frame structure design. Lastly, to make test analysis using FEA to predict any behavior under required condition. In figure 4.2 is the step on how to conduct a final element analysis FEA. There is 3 stages. For the first stage is pre-processing, then solving stage, lastly is post-processing. Okay, on the first stage we will focus on CAD modeling and FE modeling. For the second stage we will focus on depth preparation. For the final stage we will be focused on submitting to solver and result interpretation. Okay, figure 3.4 shows a simulation on a piston rod. The difference in color shows the variable values that help to predict the mechanical behavior. Okay, the most stressed part is as you can see is the red color. As long as the value of the stress is within the range of the safety of the drone, so then it is acceptable. Okay, why I'm using FEA? Because to imagine or visualize the behavior of the design that I made of the passenger drone taxi. Next is to predict of how a part of assembly behave under given conditions, to predict failure of the parts or assembly. Lastly is to reduce time and cost compared to actual physical prototype. For the expected result, we can expect that this project passenger drone is expected to be a class 2 150 range 150 to 200 kg drone. It will be fully autonomous using renewable energy as a source of energy, can carry a person from one location to another without ignoring safety aspect, predict the failure of the structure using FEA final analysis, and for future studies, only if this scope of study condition have been met, to perform the aerodynamic analysis, computer fluid dynamics CFD on the frame design using CAD software such as SolidWorks. Conclusion for this project is the drone are capable in lifting heavy objects such as human. Material for the body must be chosen wisely, and it must be light enough without holding too much weight for the drone to fly smoothly. Structure design will be run through FEA to study the structure deeply. The design must be friendly user in aspect of ergonomics. Lastly, I would run a CFD analysis, computer fluid dynamics, on the assembly design of the passenger drone. Thank you. That's all for my project. If there are any inquiries or question you want to ask, you can contact me on my email or my contact number I attach on the final slide. Thank you.